So still on evidence number one, we can still look at other populations that we can observe evolution happening in real time. And I've provided here several different links. I would highly recommend, if genetics was a tough topic for you throughout the course last year, I would suggest looking at either of these two links here, because they have a lot of really good connections to genetics that I think you could find beneficial. So to look at rock pocket mice, I know I have drawn some really beautiful mice here. And what really happened, though, here with these rock pocket mice, especially if you go and look at those other links, you'll see some of these ideas. But what happened is that there were a lot of mice that were present. And within those mice, there were variations. And remember, those variations were due to, in this case, non-harmful mutations. And so we had a mutation here that caused some mice to be darker, some mice to be kind of this medium colored fur, and some mice to be this lighter colored fur. And so what we really had was we had this population frequency here. Ooh, that's a bad graph. Let's try that again. We have this population frequency. So we're looking at our population here. If you remember, we talked about how there are different numbers that we typically are going to follow that good old bell curve. And so we have our numbers, or our frequency of the population present. We had a few of these little light mice. We had quite a few medium colored mice, and then we had a few of these dark mice. But what we actually saw here, I'm going to change my color here real quick. Sorry about that, guys. But what we actually ended up seeing is that the population here really, we were, let's say, like I said, in some sort of a desert or something. And as you can imagine, the medium colored mice, they were going to blend in a lot better here than, say, these darker colored mice, right? Which ones can you see better? Well, obviously I made that one bigger, but you kind of get the idea. And so when you have your predators or your birds, they're going to come in and they're going to attack those dark colored mice fastest. And so the dark colored mice are obviously going to have a much lower population number. And so what happened in this environment, though, is that about 1.7 million years ago, there was this this volcanic eruption. So let's make this volcano here. And it erupted. Lots and lots of lava, right? And then what happens when lava cools? Our environment is now going to be more along the lines of this dark color. But the lava can only spread so far, right? So once the lava has spread out and it's gone as far as it's going to reach and cooled off, well, you have that still sandy colored environment. Now, what do you think is going to happen to the mice here? Which mouse is going to survive best here? So in this environment, the dark colored mice are going to survive, right? They're going to be the happiest. Well, in this environment over here, the light colored mice are going to survive. So let's look at just this population. If we just look at, like, what's our population frequency going to be right here, we can see that our graph is going to shift from what we saw up here to, well, not so many light still. Light would stand out on there, right? Not so many medium, but then we get this increase in population numbers of dark mice. Doesn't mean that there's no medium mice, and it doesn't mean that there's no light mice, right? It just means that over here we're going to see that these light-colored mice, well, they stand out, right? And these medium-colored mice right here, they stand out. And so whenever a predator comes to attack this area, this new lava flow, well, which ones are going to go first? The light and the medium. That's going to allow for that dark mouse to proliferate and have this increase in population size. How did this population size occur, right? It didn't just occur overnight. So what ended up happening is that the dark mouse was able to, as I said, survive predation. It survived the selective pressure, which was the predator in this case. And when it reproduced, what did it pass on? It passed on that dark allele. And so now its offspring are going to have that dark allele. Look at those cute little ears. Yeah, okay. So they're going to have those dark alleles, and they're going to be the ones that are going to survive. And well, then now there's more of the dark allele present, and that's going to continue taking place over generations and generations. And what we see here is that a population, not an individual, but a population has evolved. So when we look at that population, and we go back to kind of some of the things we talked about regarding natural selection, there were those three main types of natural selection, right? We can look at it in terms of disruptive, stabilizing, or directional. And I think if you analyze these graphs, you're going to see this is directional selection. Our population went from having primarily medium-colored fur to now we've got these dark-furred mice taking over. So in this box here, use your own words to describe and provide evidence as to why this is an example of directional selection. And, you know, maybe if this was hard for you to understand, maybe you should go and look back here at these notes and these resources that I've provided for you. But that's the end of evidence number 1. And again, that's just observing evolution happening in populations that still exist today.